Hello guys, today we are going to discuss one important topic of JEE mains and JEE advanced especially. So that is the Faraday's laws of electrolysis. So first of all we need to understand what do you mean by the electrolysis. Electrolysis is when we pass charge through a solid substance, it split up into cations and anions. Then the cations and anions will move towards their respective electrodes where they will either stick to them or they will be liberated as gases. We will understand this with the help of a diagram. So suppose we have got one electrolytic cell, then we have got two electrodes in it. These two electrodes are joined with some source of current. So here we have got the solution in which the solid substance is dissolved. So one electrode is known as anode, another electrode is known as cathode. Anode is having positive charge, cathode is having negative charge. So when the cations and anions are split up, they are present in this solution. The cations, they will move towards cathode because cathode is having negative charge. So cations will stick on this electrode and anions, they will stick to this electrode because of the opposite charges present on the electrode, where the anions will lose their electron and cations they will gain the electron. Overall we can say that the cations and anions are getting discharged in this electrolytic in this process of electrolysis. Suppose we are taking the example of molten NaCl, molten sodium chloride. So in this process, sodium, it is cation, chlorine is chloride, it is anion. So chloride will be evolved on anode in the form of chlorine gas. So in anode, Cl2 will be formed at cathode, sodium solid, it will be formed. So chlorine is a gas. So this is the some idea of electrolysis. Our main topic is the Faraday's laws of electrolysis. So first topic that we have got is the Faraday's first law of electrolysis. Faraday's first law. We have two laws of Faraday's first law and then the second law. Second law is the advanced version of the first law only. So first law of Faraday says that the mass of a substance deposited, we will write the equation, the mass of a substance deposited or liberated on any electron is directly proportional to the amount of charge passing through it. Amount of charge passing through it. So this thing we can write in the form of equation is W is directly proportional to Q. Q is the charge, W is the mass or weight, whatever it is depositing on the electrode. So to remove this proportionality, we will introduce one ECE, electrochemical equivalent Z. Now we know Q is equal to I into T. So this will become W is equal to Z into I into T, where I is the current, T is the time. When you pass current from anything for a particular time, its multiplication, it will give us the charge, amount of charge. So we have got W is equal to Z into I into T. Now what is Z? Z is called electrochemical equivalent. Okay, so Z, value of Z is equal to equivalent mass divided by Faraday. What is 1 Faraday? 1 Faraday, value of 1 Faraday is equal to 96500 coulomb. This value is the charge present on 1 mole of electrons. Now we know what is equivalent mass. We should know equivalent mass. Equivalent mass is equal to molar mass divided by n factor. N factor is, it can be acidity, it can be basicity, or it can be the charge present on it. So here, introducing this equation in this, so we will get W is equal to W is equal to M into I into T divided by N into F, where M is the molar mass, I is the current, T is the time, N is the N factor, and F is the Faraday. So this is, we have got the Faraday's first law of electrolysis. We have to use this equation. Based upon this equation, we will solve two questions from the previous year JEE. One question is from 2015 and another question is from 2018. I have got the equation. So this is the Faraday's first law of electrolysis. Again repeating, the mass of substance deposited is directly proportional to amount of charge. More the charge you will pass, more there will be substitution. Lesser the amount of charge you will pass, there will be lesser amount of substitution. So just using these values, we have got this final equation. Okay, so based upon this topic, we have got numericals. Two numericals I will solve today. These two numericals are from the previous year JEE. I have got the equation of these numericals. So first equation is question number 1. It is JEE 2008 question. Okay, so its question is electrolysis of aqueous NaCl, sodium chloride dissolved in water, was carried by passing 10 milliampere current. The time required to liberate 0.01 mole of H2. So options are, first option is 6.4 into 10 raised to power 4 seconds. B option is 9.15 into 10 raised to power 4 seconds. C option is 19.3 into 10 raised to power 4 seconds. And D option is 0. So we will solve this question with the both the methods. One is easy method, one is the formula method. So first of all, I am using the formula method. So we have to use 0.01 mole of hydrogen should be liberated. So we can say number of mole is equal to given mass upon molecular mass. When this hydrogen H positive plus electron gives H2. So 2H positive plus 2 electron, we are getting this thing. So here, given mass, we have to calculate number of mole is 0.01. Molecular mass of hydrogen, as we can say H2, it is 2. So X is equal to 0.02 gram. We have got the value of mass, that is the given mass. Now we know W is equal to Z into I into T. We have to calculate T, time. So this will be equal to 0.02 is equal to Z. Z is equal to molar mass upon N into F. So what is the molar mass of hydrogen? 2, N factor 2 into 96500 coulomb into, what is the current? That is 10 milliampere. 10 into 10 raised to power minus 3 into T. So solving this equation, we will get cancelling this thing. So 0.02 into 96500 is equal to 10 raised to power 10 into 10 raised to power 3 into T. So taking this side, this value here, 10 into 10 raised to power minus 3 is equal to T. So we know we can solve this just for the idea. When we have got this thing, sometimes we need not to do the whole calculation, just multiply. 965 multiply by 2, 5 2s are 10, 6 2s are 12, 3, 19.3. So do we have any option 19.3? Okay. So this is the right option, directly we can take. This is the first method that we can solve this question by using this formula. Okay. The second question we have got, now we will use the mole concept. From here we know 2 mole of electrons. 2 mole of electrons are giving us hydrogen gas. Okay, or we can say it is giving us 1 mole of hydrogen gas. Clear? Or we can say 2 Faraday charge is giving us 1 mole. Applying unitary method, 0.02 Faraday will give us 0.01 mole. Is it clear? So applying this question, we have got the charge now. Now what is W is equal to Z into Q? Q is equal to I into T. So Q, what is Q? It is 0.02 Faraday is equal to I. I is 10 milliampere. 10 into 10 raised to power minus 3 into T. So T is equal to 0.02 into 96500 divided by 10 into 10 raised to power minus 3 into. So this is again we are getting this answer 19.3 into 10 raised to power 4 second. This is how we can solve easily. This method is more easy for JEE Advanced. We know the questions are tough, so it will consume the time. This is easy method that we can use. Otherwise, this method is also applicable. That is the mode concept. So both ways we can use this. We can solve this question. I hope you understand. Second question. One more question we will attempt from JEE 2015 question paper. That was in JEE Advanced 2015 question paper. So I will write the equation for this question. Yeah, it is question number 2, JEE Advanced 2015. 2 Faradays of electricity is passed through a solution of copper sulfate. The mass of copper deposited is, option A is 0 gram, option B is 63.5 gram, option C is 127 gram, option D is 2 gram. Now, how to solve this question? Once again, the same thing we will apply. First of all, I will apply the formula for this equation, the Faraday's formula. Second, we will use the mole concept. So now we know W is equal to Z into I into T. Okay, this is the formula we have got. So I into T is equal to Q. I can write here Q. So it is equal to, for copper, the equation will be Cu2 positive plus 2 electron giving us copper solid. Means 2 electrons are there that we have to add. So Z value we can put M into charge is 2F, 2 Faraday, divided by 2 electrons and factor into F. So directly cancelling 2F and 2F. So W is equal to molar mass of copper, that is 63.5 gram. Easily we can attempt this question. This is the first method. Second method is very easy. Mole concept, applying mole concept. From here we can say 2 mole of electrons are giving copper. So what we can say, 2 into 96500 coulomb charge is giving us 63.5 grams of copper. This is the most easy. So 96500 is the 1 Faraday. So we can say 2F gives us 63.5 grams of copper. The right answer is option B. This is the better option. Using mole concept, easily we can solve this question. Okay. So next we have got the Faraday's second law of electrolysis. I hope you understand the solution. Now we will solve the Faraday's second law of electrolysis. It is nothing easy here. It is very easy, and this law is advanced version of your Faraday's first law. Faraday's second law of electrolysis. Now what do it say? It says that if same amount of electric charge, if same amount of electric charge is passed through different solutions, then what will happen? Then the amount of substance deposited, the amount of substance deposited is directly proportional to its equivalent mass. Okay, so this is the second law of Faraday for electrolysis. Okay, so for this thing, let us set up one cell. Here we have got cathode, anode, and this is we are having zinc sulfate solution. Here we have got copper sulfate solution. So when we have to pass equal amount of charge from both the solution. So either we can pass same charge for the same time, or we can join them in series. Okay, so let us join them in series. So it is your anode. Anode is what? Negative, positive, negative, positive, and negative. This is the cell we have got. Now this is the setup for this second law. So from here we can say the molar mass of zinc. Molar mass of zinc is equal to equivalent mass Z into Q, or we can say equivalent mass of zinc divided by F NF into Q. Okay, equivalent mass of copper is equal to equivalent mass of copper divided by NF into Q, applying the Faraday's first law. Okay, if you divide these two equations, what I will get? Mass of zinc divided by mass of copper is equal to, this will be cancelled. So what we will get? Equivalent mass of zinc divided by equivalent mass of copper. So this is Faraday's second law of electrolysis. So it is nothing but just the advanced version of second law of thermodynamics. So this is our JEE advanced topic, 2 metals we have solved. So thank you very much for this video. Thank you very much.